we'll take one more example for priority scheduling algorithm. Non-preemptive you can do yourself. I'll just explain your preemptive, and they have just given the priority as follows. I'll just give least number. Least number is given highest priority. Okay. So I'll just write the Gantt chart. I'll just go with preemptive. Non-preemptive you can do. Okay. As you know, whenever they give preemptive, what happens? Whichever process arrival time 0 is there, that should execute. You can just see here, two process arrival time is having 0. So at 0 second, which process can execute? Your P1 can execute, your P2 can execute. It is having burst time 10, it is having burst time 1. I should not check with your burst time, I need to check with what priority. And this is having 3 priority and this is having 1 priority. So this is your process, this is your seconds, so this is your burst time and this is your priority. So at 0 second, which should execute first, P1 or P2? Which has more priority? I have just given least number is given the highest priority. I mean P2 has to execute. How many seconds is there? 1 second. So it will execute P2. Only 1 second is there because I need to 1 second it will execute. Hope you understood. Now no more process will come at first second. Left out with what? At first second only process that can execute is your P1. It is having burst time 10 and the priority is 3. No more process is there. So I need to execute until what? Until your next process arrival time. That is what here? That is your 3. To make it 3, how many seconds your P1 has to execute? 2 seconds. If it execute 2 seconds, left out with what? 8. So P1 will execute 2 seconds. So 1 plus 2 is what? 3. Now at 3 seconds, P1 will execute. P2 completed the task. P2 burst time was 1 completed. So then at P3 second, your P3 can execute. P3 can execute. P1 is having left out burst time is what? 8 and priority is what? 3. P3 burst time is how much? 2 and priority is what? 3. Here you can just see complication. Both process is having same priority. Both process is having what here? Same priority. To execute until what? Until your 5 second. Which process can execute? From 3 to 5. Both processes having same burst time. So at that time what I need to consider is which process came first? Your P1 came first. To make it 5, if it executes 2 seconds, remaining is how much here? 6 seconds. That is P1 only will execute till make it what? To make your 5 seconds. Now again I'll just write seconds, process, burst time and priority. Which all process can execute at 5 seconds? Your P1 can execute, your P3 can execute and your P4 will come. What is the burst time of P1 left out is 8, sorry, it is 6, P2 completed, P3 is how much burst time? 2, P4 burst time is how much? 1, and what is the priority? It is having 3, P3 is also having 3, P4 is having how much? 4. P4 is having what? 4. So here, what happens? I need to execute still how many seconds here? I need to execute till 10 seconds. I need to execute till how many seconds here? 10 seconds. So which is having more priority here? Which is having more priority here? Both processes having same priority. P1 also 3, P3 also 3. So which I can execute? I can execute your P1. If it is going to execute 5 seconds, remaining is how much? 1 second. If it is going to execute how many seconds here? 10 seconds. Okay, hope you are clear. How many seconds it has to execute is 5 more seconds has to execute. So P1 will execute 5 more seconds to make what here? To make 10 seconds. Hope you understood. Now at 10 seconds, which all process can execute? P1, P3, P4 and the next process which one here? P5. P1 is having left out time is 1, priority is 3, P3 is 2, priority is 3, P4 is 1, priority is 4, P5 is having burst time of 5 and priority is what? 2. At 10 seconds, after 10 seconds no more process will come. I'll just go with non-preemptive which is having more priority. least number is given the highest priority, which is one here P5. How many seconds it takes? 5 seconds. So P5, 10 plus 5 is how much here? 15. Done. Okay, next, which are more least number, which is the least number? P1 and P3, same it is having. So which came first? P1 came first. How many seconds is there? 1 second. Execute. So P1 will execute for 1 second. Done. Okay, next, which are more priority? P3. 3 is there. 2 seconds it is to execute. So P3, if it execute for 2 seconds, it becomes what? 16 plus 2 is 18. Last one is P4 is having priority 4 and burst time is what? 1. So P4 to execute 1 second, it becomes what? 19. 18 plus 1 becomes 19. See here, total burst time is what here? 19. Hope you understood this one. Okay. Now I'll just go with completion time. P1, here is there, here is there, here is there, here is there. So here you will need to construct towards right whatever it is there. P1 completion time is what? 16. P1 completion time is 16. P2, only one here, completion time is 1. P3, here it is a completion time is 18. P4, here last is a completion time is 19. P5, here it is a completion time is how much here? 15. Now turnaround time, completion time minus arrival time, 16 minus 0 is 16, 1 minus 0 is 1, 18 minus 3 is 15, 19 minus 5 is 14, 15 minus 10 is 5. Waiting time, turnaround time minus burst time, 16 minus 10 is 6, 1 minus 1 is 0, 15 minus 2 is 13, 14 minus 1 is 13, 5 minus 5 is 0. So that's it. Okay. Calculate average waiting time. Average waiting time is what? 6 plus 0 plus 13 plus 0 divided by total number of processes. How much here? 5. So I'll just check it out how much I'll get. I'll calculate average waiting time for this process will become 32 divided by 5. Here 32 divided by 5. So 6 point you will get 4 milliseconds. 6.4 milliseconds average waiting time. Average turnaround time. Okay. 16 plus 1 plus 15 plus 14 plus 5 divided by 5. Okay, how much I'll get is I'll calculate. Okay, something around 51 divided by 5. 51 divided by 5. Okay, something 10.2 milliseconds. 10.2 milliseconds. That is your average turnaround time. Average waiting time is 6.4 milliseconds. So this is preemptive priority. I've just given least number is given the highest priority. Hope you understood. I'll stop your priority scheduling algorithm. The last algorithm, round robin, I'll discuss. Thank you. The last algorithm is your round robin scheduling algorithm. As the name indicates, round robin scheduling algorithm, it is designed for time sharing system. It is designed for what? Time sharing system. So normally what happens is round robin scheduling algorithm, it is similar to your FCFS. So what happens is whichever process that came first, that only will execute first, but it is designed for what? Time sharing system, time sharing environment. So what happens is, in other things what happens is there is given the priority, but here all the particular process is given the equal priority. All the particular process is given the equal priority. Every particular process is going to execute only for small unit of time. Every process will execute for what? The time quantum, only small unit of time. So for round robin scheduling algorithm, what happens is they need to give what? A time quantum. So every process will execute only for the time quantum you have specified, and it is going to execute what here? The next process. And round robin. So this will round robin fashion will execute until what? Every process total time whatever it is been completed. That's it. And here the round robin is totally what I can say preemptive scheduling algorithm. There is no non-preemptive. Why? Because every process is going to execute only for specified time quantum and preempt to what? The next process. It repeats and go back to again to your first process until what? total time is finished. So the name round robin. That's it. Hope you're clear. And whenever they don't give arrival time, what happens is whenever you write your Gantt chart, you write right. That is called as running queue. But whenever they give arrival time, you will use one more queue called as ready queue as a FIFO queue along with what normal Gantt chart. The Gantt chart is called as running queue. Okay, when you use this particular ready queue means whenever they give arrival time. Whenever they give arrival time. So this is your round robin scheduling algorithm. I'll explain with a problem. I'll explain with this with a problem. Yeah, let me consider three process for round robin. I said it is totally preemptive. And for round robin, they should specify what time quantum. They should specify what time quantum. So I'll just write the Gantt chart. I said it is similar to what? It is similar to your FCFS. Which process will execute first? Your P1 will execute first. For how many seconds? Only it executes for what here? 4 seconds. So P1 will execute for how many seconds here? 4 seconds. Why? Because round robin is a time sharing environment. It only executes for the time whatever you are specified. And then what happens? It is going to preempt your next process, FCFS. After P1, next process which one here? P2. And before that you count 24 plus 3, 27 plus 3 is so much? 30. You need to get at the end. Now P1 has executed 4 seconds, remaining is how much? 20 seconds. Now P2, it has to execute 4 seconds, but only burst time is how much? 3 seconds. So at that time what happens? Whatever the time is there, you execute only for that second. So only 3 seconds is there. So 4 plus 3, it becomes what? 7. P2 completed. Next P3 process, again it is having only 3 seconds, only execute for that second. So 7 plus 3 becomes what here? 10. Done. Hope you are clear. Round robin. Again it goes to first process. Again P1 will execute for how many seconds here? 4 seconds. That becomes what? 14. No more process there. P2 completed. P3 completed. So P1 only will execute. Keep on executing. For how many seconds? 4 seconds. 4 seconds. So straight away. Remaining is how much here? 16. So this becomes what? 14 plus 4 is 18. So just 4 seconds I'll execute. So P1, that is how much? 22. Next P1, that is how much? 26. Next P1, that is how much here? That is how much? 30. That's it. So 30. Until 30, I will keep executing. Sure. After this, P1, next 4 seconds, it becomes what? 12. Next 4 seconds, it becomes what? 8. Next 4 seconds, it becomes what? 4. Next second 4 seconds, it becomes 0. That's what. Total to make 30, I have done. That's it. Hope you are clear with this. Now, whenever they don't give arrival time, I don't take completion time, turnaround time, waiting time and all. So straight away I will take waiting time. P1 process towards right you check. Here it is 26. Waiting time I need to check, right? Here it has executed 4 seconds. Here it has executed 4 seconds. Here 4 seconds. Here 4 seconds. Here 4 seconds. It has executed. Means it has traveled, not waiting time. I need to take only what? Waiting time. So I should subtract here. Waiting time is 26 seconds minus 4. It becomes what? 26 minus 4 is 22. Okay, so straight away 4 seconds, 4 seconds, 4 seconds, 4 seconds, 4 seconds. So 1, 2, 3, 4, 5. So 5 4 is 20. So 26 minus 20. That is how much here? 6 seconds. You got it? How do you get this one? So P1 waiting time left is 20 seconds, 26 seconds. Here it has not waited 4 seconds. 4. Here not waited, executed 8 seconds. Here 12 seconds. Here 16 seconds. Here 4 seconds, 20 seconds. So 26 minus 20 is what? 6. That's it. So P2, only one process there. After 4 seconds, P2 has got the chance for execution. 4. So P3, after 7 seconds it got. That's it. This is your waiting time. So P1 plus P2 plus P3 divided by 3. So average waiting time will become what? 6 plus 4 plus 7 divided by 3. So that is 17 by 3. Hope you are clear with this. 5.7 milliseconds. 3 by 15 to carry 5.9 milliseconds. 5.9 milliseconds. Now average turnaround time. So towards right whatever is your calculate. So P1 it is 30. P2 it is 7. P3 it is 10. So here 30 plus 7 plus 10 divided by 3, that is 47 divided by 3. So 47 by 3, I'll calculate, you'll get 15.6 milliseconds. 15.6 milliseconds. So this is your average turnover time. So this is your round robin scheduling algorithm. Simple. Whenever they don't give arrival time. Hope you are clear. Whenever they give arrival time, along with this particular Gantt chart, you need to have one more queue called as ready queue. So this would be called as running queue. Okay, this is called as running queue. So in your next video, I'll discuss with preemptive. That is your arrival time. Whenever they give arrival time. But round robin is totally what you can say. It is non-preemptive. Sorry, it is preemptive. Round robin is what? Totally it is preemptive. So next class I will just go with for preemptive itself. It is preemptive whenever they give arrival time, how to calculate. So thank you.